Good morning, students. Good morning, math enthusiasts. In our previous discussion on solutions to right triangles, I have mentioned about applying it to real-life situations. Today, we are going to discuss about some applications of solutions to right triangles. We shall be considering about simple word problems involving angles of elevation and depression. Before we proceed with some applications, let me discuss first the definitions of the angle of elevation and the angle of depression. To start with, the angle of elevation is the angle formed by the horizontal line of the observer's eye level and the line of sight from his eye towards his observed object, when the object is above him. If you look at the picture below from mathpitsnotebook.com, this line is the horizontal line of the observer's eye level. And this line is the line of sight from his eye towards the observed object. In this case, the top of the tree. Notice that his observed object is above him or above his eye level. So there is an angle formed, in this case, x degree, which we call the angle of elevation. Observe further that if we create a straight line from the top of the tree towards the base of the tree, we have created a right triangle. The angle of depression is the angle formed by the horizontal line of the observer's eye level and the line of sight from his eye towards his observed object, when the object is below him. In this picture from mathpitsnotebook.com, the broken line is the horizontal line of the observer's eye level, and this line is the line of sight from his eye towards the observed object, in this case, a boat. Notice that the boat is below him or below his eye level, because the observer is actually on top of the lighthouse. The angle formed x degree is what we call the angle of depression. Many students commit mistakes in labeling the angle of depression. Some of you might consider the angle formed by line segment BC and line segment AB. That is not the angle of depression. Always remember that the angle of depression is always connected to the horizontal line of the observer's eye level. We shall now start discussing some applications of solutions to right triangles. This first example was taken from www.mathpitsnotebook.com. The problem is, find the shadow cast by a 10-foot lamp post when the angle of elevation of the sun is 58 degrees. Find the length to the nearest tenth of a foot. The first step in solving the problem is to draw an illustration. First, let's read again the problem slowly and partially. Find the shadow cast by a 10-foot lamp post. Let us draw a lamp post measuring 10 feet. When the angle of elevation of the sun is 58 degrees, we now draw a sun and create a line from the sun to the lamp post to a particular point on the ground of the lamp post. So since it says angle of elevation, then the angle 58 degrees is located on that particular point on the ground. Then we connect that particular point to the foot or the base of the lamp post. Notice that we have created a right triangle. Remember that in our illustration, we should be able to draw a right triangle. This right triangle will become our basis in creating the equation to be able to solve the problem or determine the value of the unknown that we are looking for. The question is find the length to the nearest tenth of a foot. We are actually going to find the value of x, which is the representation of the length of the shadow of the sun that is cast by the 10-foot lamp post. Do not be anxious when we start using variables such as x. x is simply a representation of an unknown value that we are looking for. In life, not everything we need and want are directly provided to us. We still have to work for it, even work hard or struggle to obtain or achieve it. So while it is not available to us yet, we have to represent it as our ideal man, ideal car, ideal house, and even ideal job. In math, when a value is still to be found, we represent it by a variable x, or y, or any letter of the alphabet. By the way, this lamppost was taken from www.mywonderfulwalls.com. I have drawn and cropped the illustration from the Paint software. Let us now start with our solution. Since we are looking for x, we look into its relationship to the given values. What is x in relation to angle 58 degrees? Correct. X is an adjacent side of angle 58 degrees. Now, what is 10 feet in relation to angle 58 degrees? 10 feet is the opposite side of angle 58 degrees. What particular trigonometric functions have a definition that involve the opposite side and the adjacent side? Correct. The tangent and cotangent functions. But we will use the tangent function for convenience in using our scientific calculator. So by substitution, we have tan 58 degrees is equal to the opposite side 10 divided by the adjacent side x. Now, just like we have discussed in our previous discussion on solutions to right triangle, we do cross multiplication so that the unknown variable will be placed on the left side of the equation and the known values will be placed on the right side of the equation. In this case, we have x equals 10 divided by tangent 58 degrees. Using our scientific calculator and pressing the keys on the same format, x is approximately equal to 11.79178403. Therefore, the length of the shadow is approximately equal to 11.79 feet. Always end your solution with a conclusion to check if you have answered what is asked in the problem. Example number 2 is taken from www.themathpage.com. Here's the problem. Find the distance of a boat from a lighthouse if the lighthouse is 100 meters tall and the angle of depression is 6 degrees. We will now start with an illustration, but of course, we will read the problem with sketching our illustration. Find the distance of a boat from a lighthouse. So we draw a lighthouse and the boat. Then create a line that connects the base of the lighthouse and the boat. We shall represent this line by letter D. D meaning distance. If the lighthouse is 100 meters tall, so we will create a straight line from the base of the lighthouse to the top. And we shall label it as 100 meters. And the angle of depression is 6 degrees. Automatically, we shall write a horizontal line and draw a line of sight from the top of the tower to the boat and label it as 6 degrees. Now, if you look at the illustration, have we created a right triangle? Yes, we have created a right triangle. By the way, these pictures of the lighthouse and the boat were taken from www.shutterstock.com. Then, I have drawn and cropped the illustration from the Paint software. In our illustration, notice that 6 degrees is outside the right triangle form. The right triangle then has only two given parts, the 100 meters and the right angle. We need one more part. Since the illustration of a right triangle on the left lacks given values, so we will improve the illustration. In this new illustration, we can now see a rectangle. Recalling our geometry class on rectangles, particularly on parallelograms, the opposite sides of a parallelogram are congruent. This means that if we can also label this as 100 meters, then its opposite side can also be labeled by 100 meters. Similarly, if this side is D, then we can also label this side as D. Moreover, our geometry class also tells us that the opposite side of a parallelogram are parallel. So this side is parallel to this side. And so the alternate interior angles formed by a transversal are congruent. This means that if this angle is 6 degrees, then this angle is also 6 degrees. So what does this information tell us? This means that in trigonometry, the angle of depression is equal to the angle of elevation. In this illustration, we have formed two right triangles. It is up to you if you want to consider the upper right triangle or the lower right triangle. For this particular example, I would like to focus on the left or on the lower right triangle. Observe that in the illustration, the opposite side of angle 6 and the adjacent side of angle 6 are involved in this problem. So, we will use the tangent function. And by substitution, we have tangent 6 degrees is equal to the opposite side 100 divided by the adjacent side D. After cross multiplication, the unknown variable D is on the left side of the equation and is equal to the known values 100 over tangent 6 degrees. Using your scientific calculator, by pressing these keys with the same format, you will find that D is equal to 951.4364454. Therefore, the distance of the boat of the lighthouse is approximately 951 meters. Example number 3 was taken from www.mathbeatsnotebook.com. The problem is, a ladder leans against a brick wall. The foot of the ladder is 6 feet from the wall. The ladder reaches a height of 15 feet on the wall. Find, to the nearest degree, the angle the ladder meets with. A ladder leans against a brick wall. So we draw a brick wall and a ladder that leans against a brick wall. The foot of the ladder is 6 feet from the wall. So, we draw a line connecting the base of the brick wall to the foot of the ladder, and we shall label it as 6 feet. The ladder reaches a height of 15 feet on the wall, so we look at the point when the line of the ladder intersects with the line of the wall. From the point downward to the base of the wall, we label it as 15 feet. Find the angle the ladder makes with the wall. Now, we look at the ladder and we look at the wall. And so we look at the angle the ladder makes with the wall. Now we look at the angle formed by the intersection of the line of the wall to the line of the ladder and label it as x degree, the unknown value that we are looking for. So the illustration used here was taken from www.mathbeatsnotebook.com. The illustration on the left tells us that a right triangle was formed, with again, two legs of the triangle involved. So we use the tangent function. By substitution, we have tangent degree is equal to 6 over 15. Using your scientific calculator, press the shift function key or the second function key, then tangent, then 6, then ABC or the fraction key or the division key, then 15 equals. You should be able to obtain 21.8 degrees. To transform this value to the degree minute second notation, then after the equal sign, press the degree key to see 21 degrees 48 minutes and 5.07 seconds on the screen of your scientific calculator. Therefore, the angle formed by the ladder and the wall is 21 degrees 48 minutes 5.07 seconds or 21.8 degrees. Example 4 was taken from www.ck12.org. Here is the problem. Mark is flying a kite and realizes that 300 feet of string are out. The angle of the string with the ground is 42.5 degrees. How high is Mark's kite above the... We will now start with the illustration while reading the problem again. Mark is flying a kite. We will draw Mike and a kite and create a line that connects the kite and Mark, and realizes that 300 feet of string are out. So we label the line that we have created by 300 feet. The angle of the string with the ground is 42.5 degrees. So, if we draw a horizontal line that represents the ground and connect it with the line that has been created between Mark and kite, then we have formed an angle. And we label this angle by 42.5 degrees. How high is Mark's kite above the ground? Since we are looking for the height of Mark's kite above the ground with a vertical line connecting the kite and the ground. Look at the figure. We have created a right triangle. By the way, the pictures of Mark and kite were taken from www.dreamstime.com and www.vippng.com respectively. I have drawn and cropped the illustration from the Paint software. Since we have already created a right triangle, we will now start identifying the appropriate trigonometric function to be used. Observe that the parts that are involved in the problem are the opposite side of angle 42.5 degrees and the hypotenuse. The trigonometric functions that are defined in terms of the opposite side and the hypotenuse are the sine and cosecant functions, so we use the sine function for convenience. Thus, by substitution also, sine 42.5 degrees is equal to the opposite side h divided by the hypotenuse 300. After cross multiplication, h is equal to 300 times sine 42.5 degrees. From the calculator, you should get 202.6770623. Now, we have answered what is asked in the problem. Therefore, Mark's kite is approximately 200 feet high above the ground. As a recap, in your illustration of the problem, make sure that a right triangle is formed. This right triangle becomes your basis in selecting the appropriate trigonometric function to use in order to solve for the required unknown value in the problem. That ends our discussion for today. Thank you very much. Remember, math is easy to learn when one learns with enthusiasm. Bye!